Hello, everyone. Hello and welcome. We're going to be continuing our game dev project today. Before we do, though, let's check in with the kitties. We do have 4 of them visible right now. Hello, Drez. Welcome. Let's see, we have Sky in the tree, Ember near the keyboard. Nobody has preempted her spot yet. Oh, okay. Mason on the bed and Sammy getting some food. Good times. Kitties indeed. And Molly is underfoot. Cough. When last we left off, we had created a core location for our rendering device. Since then, I've been doing some research, and that's probably going to change. At the very least, there will be rendering devices in context. But ideally, we don't have to go down that road. But what it lets us do is that we can... words and stuff. We can proceed into the avoidance shader. We are still going to need to stack up some logic, but at the moment, how we're going to address it is to put it as we're just going to load the shader in our existing physics logic and see from there. Because as far as flow, we're wiring it into the behavior. It's not going to be in the behavior long term. That behavior is the kind of demonstration bed for this. Okay, so here, let's real quickly here. Oh, buttons. Let's walk through this. It is still so offensive that there is a co-pilot button in the albeit crude art program. The disparity might be like a daylight savings time thing. Because I believe the time just ticked over recently. This is still, in theory, the same time. At least for the past little bit. Okay, so what we've already got is a series of entities and their positions loaded into a gigantic data set. We will need to add a little bit of data to them. Hopefully it won't be a big deal. We do have that padding slot. So for the moment, the idea is that entities will only avoid their own kind. And that this is almost entirely, or pretty much entirely, for monsters. But there will be types of monsters or types of spawn that say, ignore avoidance, like you don't do avoidance. We'll see how that goes, like how we have to implement it, but it might not need to be anything special. So then while we're doing this, each one of these is going to create kind of a push out from it. Here, let's just use a circle. Stuff like that. You know, but shaped consistently. Let's put one close here. A couple real close here. So what this does is it creates areas that entities don't want to be. So when we look at how we're moving, we're going to be looking at the areas that are around it. There is a little bit of fiddling here in that entities are not going to be where they currently are under this logic. Ideally, there would be a way to get around this. But we'll have to see. That is, this entity could potentially be subject to its local avoidance, the way it's set up. Yes, yes. This is so they don't clump together. And how we're going to be accomplishing that is to create sort of a move away from this spot logic. So that's one flaw that we already have, is that each one of these entities is going to be subjected to its own kind of bubble. Now, ideally, that won't really matter. It will only matter in cases... Here, So when they're alone, it doesn't change anything. The avoidance vector is not going to alter their current path. We're going to use this as sort of a twisting force. That is, it won't be additive. It's either going to be, well, it'll be normalized, let's say. So it's going to ultimately like push the vector in different directions. So this one is going to have an opposing force applied to it. That's going to push it away from this one. So in this particular case, there is going to be like an opposed vector here. That is potentially going to say this doesn't matter. You can't stop that particular vector because it's going to get squished. But we might still be able to deal with that. Put another way, if the vector is shortened as a result of the change, we may leave it shortened. So in this scenario, it would be squished. In this scenario, we have a vector in this direction, which will definitely squish it, but it's going to twist it up a little bit. It's going to pull it up in this direction. So in some of these cases, it won't. Yes, we're going to have layers, is that we'll have what the behavior says to do, what the wall movement flow says to do. So if you're pushed away from walls, and then in this case, where they're going to get suggested movement, but then they're going to get this vector as well. Again, it's the squishing force that we need to worry about. Is how much can we make it stop? Hey there, Sleepy. And welcome back then. We're puzzling through our avoidance logic. We're still working on that game. So we're just going to run with it for now. We're just going to try to add in the vector that we were going to previously. What that means is that we're going to have the same general structure. Let's get that one up here. Yep, we're still working on it. It is non-trivial. But we've made big strides in different directions, and we've also been learning a lot. We have a lot of our logic working at a much higher performance level than we did before. Stably so. We currently have approaching 1,000 things. Let's amp that up. Now it's going to start slowing down noticeably here. The reason that you've got the black background is that is dynamically generated flooring space. That is the image it is generated from. While there are some gaps in like weak spots in it currently, we stepped away from the pixel tile map. We'd been doing a lot with that, but as far as building the map, we've shifted to something where you can just draw the image. Like, this is ad hoc. I could go in and change this image, and it will do avoidance of the walls based on whatever you give it. Like I said, there are still, like, numeric dials that I would need to tune, but currently we're sitting at 16,000 things. We're down to 8 frames a second. So let's cool it down by 2 powers of 3 here. It takes a bit for them to die off. The way the system is set up is that game time only happens in fixed slices. Real world time passes effectively faster than game time. Game time will never pass faster than real world time. It will only ever be slower. But it's in fixed slices. So we don't get that the game is slowed down a lot and the delta time is thus stacking up. Usually if we can get down closer to 10,000, we'll be in a better place. Been doing good. Trying to get the stream schedule stable again. A bit wobbly in that regard, but we're getting there. And the game dev is enjoyable. Okay, we're back up to about 20 physics frames a second at 6,000 things. We hit 4,000 things and we are ramping up. So this is with about 2,400 things. We're going to give it more things. We're going to add another power of 3. So at about from 2000 to 4000 is where we start getting some frame, like tangible frame loss. Cats have been doing good. We got Sammy and Mason are on the bed there. This guy is getting some food and Ember's watching TV. I have a constant looping feed of like birds at bird feeders there. Ember really likes it. Okay, at about 7,000 things, we're at about 20 frames a second. Tangible differences as far as amounts and what kind of performance. What we're showing here is our current worst case scenario is piles of things doing complex motion. Orbital motion is not simple motion. Straight lines curving towards targets, those are all pretty straightforward, but orbital motion has a lot of like moving parts. Yeah, we're just under 60 at 2400 things. Is there more optimization we can do? Oh, okay, we're over 60 now. Distinctly possible. I mean, you can develop allergies over time. Might be just some change in the environment or something about the food or any number of things, you know? But it's good that you're keeping an eye on it. Make it so that enemies combine into one singular thing, and then we could split the damage apart. Definitely possible. Right now we're brute forcing a lot of stuff on the GPU, and there's elements of that we can tune. But it gets fiddlier once we go down that road. And so we want to be cautious. Effectively, we could spin off threads for handling the GPU interactions that we're doing so that we're not blocking the kind of the interior Godot thread and costing more performance than need be. But going down that road puts us at the step that I want to do after this one, and that's changing game state management to a single or multi-part state machine, so that the transition between the states is not the linear flow that it currently is. Right now we have in each physics frame a method that goes kind of line by line saying first this message, then this one. What I'd prefer is to have it so that we effectively instantiate watchers that say, I am now in the game start step. I do my thing when I come into being. And perhaps I sit there and do other stuff. I watch for some messages, that kind of thing. But until the trigger for that step or that stage to say, I am changing stages now, we don't do anything else. But yeah. So right now, 2400 things is a lot. Is a lot. Yep, we're real close to the next 1,000 mark. So right here we can have 1,000 things, enemies and bullets, and sit at 120 frames or so. Little wobble. This is still a lot of things. In a Vampire Survivors sense, the screen is full at about 700 enemies. And that's being generous. There are variable sizes and whatnot. And we are doing a lot of that, Drez. We are doing a lot of avoiding the built-in stuff. Like, a lot of the built-in stuff. There's still more that we can cull, and that will be a non-trivial thing to do. But it's an iterative process. Hey there, Key. Welcome. We're really just getting rolling here. Okay, we have avoidance. Okay, there's messages. We have avoidance flows. Okay. Hello, Sky. Hey. Giving Sky some chin scratches. He wants intensive attention now and again, so he gets to have it. I haven't looked at how old he actually is. I don't know if the shelter had the exact number to begin with, but he's getting on in it. I believe he's around double digits now. If not close to. He is reaching the kind of eternal pet age. He's not showing like elderly pet behaviors. He's still perky, but he's reaching the point in age where it's really, it can now go on for however long. Yes, it's that it's that point where they've passed through full adulthood, and passing into old age could happen at any time, but may not. And a lot of hair dander in your undercoat, sir. Guys jumped on my lap, so Sherbet, in following him, has started leaping back and forth across my headrest. Okay, both arms occupied now. Sky will sit on the headrest, but it's infrequent. Sherbet is infrequent as well, but as far as places that he'll kind of snuggle up next to me, this is it. The only other time he gets close is if I haven't gotten up in time to refill the food bowl. Then he'll be very nearby. Like, not meowing or like batting at me or anything like that. Just, sitting nearby, making eye contact. The other one that has started to be a headrest cat is Sammy. Okay. Avoidance flow. Add folder. I'm leaning back. Oh, no. Have our shaders here. Okay, so we're going to use some of the same basic stuff here. Image params, not really what we're dealing with. No, we're talking collision is what we want to look at. Okay. Some of the naming of this needs to be altered, but we're going to have to pay attention to this. Because I don't know if we're going to have to change restrict here. So we don't need a collisions buffer. The debugging buffer can go away. The iteration buffer should stick around. Because we may need to break this up further. But maybe not. So we're going to take this bit of information here. And the corresponding, we'll do our layout and our data. Conveniently, if we do need to add more data to this, we can use this uint space here. We could swap that out for something else. For the avoidance flow, we have 2 floats. I mean, technically half floats, but we have 2 floats that we're working with that we could utilize for other values. And one thing that we could do is set up different flags in them that says, you know, these vectors only come from things like this. But that won't really work. We'd be really getting into weird space with that. So for now, again, we're saying it's only going to be enemies. Then we're going to, in the same way as the collision buffer, check. We are going to do this. I will explain this blob in a moment. We're going to get rid of that, though. And we should get rid of that in here as well. Okay. This whole chunk right here is to make it so that the work groups that I pass in are determined here. I can change that number, and it doesn't matter as far as the logic is concerned. So what we're doing is saying that, okay, each one of these work groups is responsible for some part of the flow. Now, it's necessary for this to be big enough. This resultant index needs to cap out at least the size of the input array. Right now, it's set up to be about 20,000. It's a little more than that. And it will stop if it's below, if it is not within the bounds of the data set. So we're going to take this same thing again. So we're going to remove collidable here. This is not entirely what we're dealing with. So here we're looking at, we're going to do this. if, what is it called? Okay, we aren't going to be doing the secondary loop. Not yet, James. There are a couple of things that might be not as like expansive, but highly invasive that we're going to be looking at. One is getting our shader loop into another thread. Or at the very least, just asyncing it, but primarily other thread. That's a big scary one, but it'll only be viable if we do the other thing, which is change our core flow into a state machine. So that the steps are not bound to the physics heartbeat or even the render heartbeat of Godot. Instead, they're bound to its own internal heartbeat. Now, the physics tick will start off the process with the very first state machine part of the state machine being most interested in that tick happening. But everything else would essentially be, I am in charge right now. I will change to another state when it becomes relevant. Often this kind of thing gets set up using like visual controls in some of these engines. We will be defining it in code somewhere. Okay, so we're not doing a collision check against each one. Instead, we're looking at that entity and we're going to radiate out from it. Which implies we need one of the other variables here. Okay, we're gonna... Hello, Sky. Oof. Hello. So every now and then, if he really wants attention, so with like low level of attention, he'll just lay across my lap, kind of perpendicular. But if he really wants attention, he'll kind of climb up my chest, headbutt me in the face, and want to be like hugged or held in the crook of my arm. Like he'll roll back so that his back is in the crook of his arm, of my arm. If I don't continue to pet him as he would like, he will go back to the climb up me and give me a headbutt. But sometimes he just stays against my chest and wants a hug. He's a big sweetie. Okay, so we're going to actually need to look at the floor flow code. This is the relevant part. All right, we will actually need this part. We are going to be changing a lot of the terminology in this stuff. I am currently restricted in mobility because of aforementioned cat detaining most of the right arm. Okay, so we need that, and we need this one, which will come after. We're going to have it come before the entity buffer here. We also need to change the order of the bindings in the collision one. Okay. What this does is it gives us boundaries to work in. So we're not iterating over the entities again. We're looking at just this one. There isn't an atomic add for float, but that's okay. All right. So we're not iterating over the rest of the collection. This part is what makes the collision one so expensive and need to be broken into parts. Processing, okay. Or slow typing. Index minus search range, image params, data dot search range, with a capital R. Oof. There we go. I is less than image params.data.width. As well as I is greater than or equal to 0. No, we have to do this part later. Because we want to start low. We don't want it to exceed the maximum. We can stop once it hits the maximum. It's irrelevant at that point. So this is if I is greater than or equal to 0, then for j is equal to, oh no, I believe there are limited channels in the Discord, Sleepy. I believe like most of the secondary areas are blocked. Could be wrong. I haven't looked at the rule structure in a bit. It is a for everyone's protection scenario. Let's see. Hey there, Lunar. Did I add the Planet Cowboy roping minigame yet? Not yet. No, this is not what we're doing. Okay. Back to... collider data. It is entity data. We actually need that. So the entity needs to be collidable for this. Okay. Okay, and this will be position x minus search range. There are some companies or some dev groups that when they're making games feels like at some point in the dev process a kind of a Mad Libs operation happened. Okay. If that scenario happens, when that happens, I'll have to address it as is. I'm not sure. I don't have a mechanism for automatically doing that. It would have to be manual. It's a channel roll thing. It's never come up. Okay, it's not the width. It's not perfectly the width. Okay, we need to... All right, we need a 0 position. We need a 0 position. So with the floor flow, the 0 position is the upper left-hand corner of the texture. So we don't need to worry about making that correlate to the world. So what we would probably end up needing to do is set up a where is 0 concept. And I feel like that would be in here, which complicates things. All right. Let's go down the rabbit hole here. Okay, so we have this. We're going to have a public uint pad, then a public vector2 I don't remember why I did this. Oh, no. Okay, this is for storage purposes, not for shader purposes. Okay, I remember now. Okay, so by default, this is always going to be 0. We don't actually have to put this here. So let's leave that out. So we're going to have a uint pad and then a vec2 called 0. So what we're doing with 0 is, again, creating the offset here. 0 is going to be kind of a translation. That is, every position of an entity needs to be adjusted relative to that. Or to put another way, it's adjusted relative to the center of the area we're working with being at the 0 position. So half the width, half the height is the 0. So everything needs to be offset by negative half width, half height. Negative of both. So we have a vec2 offset. Why would you do? 2, and this would be it's not smaller, it's just that we're just repositioning a box. We want the 0 of the box to be the equivalent of the upper left boundary. The center is going to be a point. Just thinking here. Okay, quick break, and then we will continue here. Gotta get the thoughts in order. Okay. So avoidance only matters when you are within a boundary of the player. So when we're dealing with the flow range here, right now, flow width and height are odd numbers because there is a center pixel that we need to generate an offset around. So how did I do that? I don't even do that with them anymore. Yeah, okay. We stopped doing that because we're not generating it dynamically. We're doing the offset on the client. Or at runtime. So let's look at that. should be in the game in the entity logic and behaviors and movement, and that is move on grid. This technically isn't correct. Because that'll truncate. Because the flow to center is 6001. Oh no, that lets us get away with it. Yeah, no. Okay. So truncating divide by 2 is we would set it to the floor just to be explicit and convert that to an integer. But that gets us our upper and lower bounds. This creates our offset. Essentially, upper bound is the offset, like the literal offset from a 0, 0 position. For how we're adjusting the map. Because if we add those, we go from one part being negative. Oy. All right. We have this marker, and by default, this is 0. At least as far as the indices are concerned. We need to make it so this 0 is actually negative. So we're going to figure out what this marker is. These are definitely straight lines that definitely cross through the center. So we figure out what this is. And the negative would be to subtract, would be to go this way. Let's second. Okay, so then our offset is here. Well, it would actually be here. So whenever we're dealing with negative space, we add this. I'm sorry, we add this to create this being the center. We're effectively moving 0 to here as far as the indexes are concerned. And we'll have to do the same thing when we're leveraging it. Again, just like the flow diagram, but with extra complexity because we have to set it up in a parallel fashion. Right, so the spatial coordinates of the entity plus the offset gives us our position relevant to the center, with this becoming negative space. Put another way, subtracting this number gives you the corresponding position if we put the 0 at where the center is. That should work. Let me double check how we end up doing that. Yes, upper bound, upper bound. Okay, okay. We're gonna try to push through the avoidance workflow, Tass. Which means creating a map that is centered around the where the player is. Integer of ceiling of area params dot width divided by 2. That looks about right. No, we don't do a ceiling of it. That's right. Because there is a central position that we're dealing with. And it's not index data size. No, wait, that is. Okay. So we get its position. Oh, okay. There's a lot of fiddliness going on here. We're doing this to just save calculation. Hey, Night Shift. Been doing good. We're making steady progress. Getting more streams in. And so it's less than the upper bound. Minus greater than or equal to. It is less than or equal to. The opposite side. Again, by doing this, we are creating one pixel in the center. Height, upper bound. Plus. If 2 negative 1 times arc range. So we are searching every position around the entity here. No, this is more complicated. We actually do need to do it akin to how the floor flow is doing it, combined with how the collision is doing it, which means we are going to be splitting this function up a lot. No. No, okay, we can still do this cleanly. All right, so this is... We have an entity. We are iterating over its search range to... Iterating over the search range. Because what we're just going to do is add the vector from our offset position to the ij position. So this is the direction from the entity to that square, to that pixel. And we're going to do that for each entity search range out. So in this case, search range is the effect influence range here. So each entity is going to alter the resultant vector, but we need to divide. We want it to have more impact the closer it is. So this is going to be it's going to be dependent on search range. So we need to invert it. We would be dividing the search range by the vector length, and then multiplying that against the unit of the direction. No, we should just be able to divide search range. Yeah. I think it's push direction dot length. Just normalizing them here. Just a second. Length of. Okay. Back on. So this is this divided by that. And then this would be equal to normalize push direction times the inverted length. Okay. Now we're going to need to set up iteration here. But I think ultimately we're okay with the iteration, with the work groups. This will be an int Okay. Yes, okay. So now we need to change the value of our output. We need one of these then. Then in the flow generator, we have a way to indicate which one of these we're setting. Okay. Back to offset. So that's what we're going to set. Not quite. Yes, okay. No, we do it that way. These will be units. The offset output position will be unit values or integer values. So we should be able to use them in this context, but we'll have to see. Okay, so it's going to be it's a little fiddlier than this part. Image height is very fiddly here. X. Check the syntax there. Oh, man. Okay. So what we need to be able to do is safely add this. In theory, they should both be... Okay, no. We need to make sure that it is added to, again, atomically. Which means we would need to round. But that gets fiddly if we do that. So we want to be able to add these vectors again to this square without impeding other ones. We're translating this down to raw pixels, so we're always going to be truncating it to some extent. If every position that we're looking at is in integers, let's see. Okay. It's not perfect, but so we're rounding them down here. And that's where we'll work from, is that it's always the rounded down position. So then we have our offsets. Those are always going to be in hard integers that we're dealing with. We don't actually have to do this here. We can do that all the way down here. It's going to be a float, though. We'd be storing it to a float. know if I want to do that. Atomic add for float would be using an extension for Vulkan. Not out of the question, though. Let's do it. Oh, come on. I keep forgetting things. Well, we'll see if that works. This is, you know, all things are suspect. Atomic add. All right, Godot, tell me all of the ways that I messed that up. $33, which implies this is wrong. Doesn't like that. Doesn't like that. Need a semicolon? Oh, let's try that. Nope. That might not actually have been the problem. Falling out 32 is the first buffer. Read only buffer name. What am I missing there? Seem to care about the syntax, or at least the Hey there, Schmuggums. Oh, that's why. been a bit. I hadn't renamed the usage of that. Then we also need to change entity data here. Next one, 056. Point at which we define iteration in our collision logic. Need this. Two and three and iteration.data 0. Okay. Next. Temp high float to temp high int in 79. As integer. We use uint in I and j. Nine. We're just letting it iterate here. It's on the push XY. Push that into an integer. That's right, floor gives us a float. $107. I don't think the extension logic actually worked. Oh, wait. Ah, dear, dear, dear. All right, all right. A and j is equal to integer of this whole thing Okay, and then we int this. Theoretically works. Okay. So we need to supply all of this with the variation being that we get the entity information buffer that is the same. We're going to be using this same buffer as we use elsewhere. We're going to be using the same iteration buffer. So we will need a unique area params and a unique output buffer and a unique iteration buffer. We could double up on the iteration buffer because we're using that the same way each time. And we're going to put this in the collision buffer for the time being. Okay, interim commit. Okay. Okay, collision still happens. The avoidance flows are still, floor avoidance flows are still happening. Okay, let's look at our collision logic here. It is a mess to jam this in here, but right now it's a spot that has it. No, we're just gonna we're gonna do this correctly. Entity avoidance data. Okay, we're not doing this part anymore. This is purely what we send up. So this goes away, which is going to cause a lot of problems. This goes away. This goes away. That and that. Everything that we had goes away. It torches this whole workflow because we have implemented it such that we are getting a rendering device. Did we? I thought we built that. Okay, we did. We have the collider buffer here. You anymore? Okay, we will need a comparable structure to this. But since we're going to be... No, we need this. Same thing. Okay. It's going to take this whole blob for a moment. And we'll strip out the bits we don't need. Don't need that. Don't need this. Okay. Then the shader for avoidance is in services. Flows. Avoidance. Science indeed, T key. That's not an avoidance in services, flows, shaders. Avoidance. Okay. Output bytes in our output buffer. Output is like the flow generator. Creating it, we need to get our output set up. Okay, so we're creating a buffer as normal for the output right here. We could just reuse it like we have been, so. Okay, but that here we go. So we're going to take the layout like that. It's not going to be that structure. It's going to be what we use for our output buffer here. Outputs. Not that. It's going to be our size layout like in the base flow generator. Width, flow height. Just so. So then we are going to create use the iteration buffers each time. Okay. It's the thing we created last time. There is a central rendering device that we have made. We're going to have a rendering device. We don't need to store the rendering device off. Flow generator is like a step behind where we are right now. Okay, we're going to go into our avoidance flow when we're generating that. A whole bunch of this stuff doesn't exist. Generator, we have floor flow image params. Okay, so what we're doing here is saying this only exists here. We have a pad value and we have 0. output buffer. Give us our avoidance area params. Compute pipelines, uniform sets. We have our iteration bytes. Array. Which is partial.size of that. Okay, so we have an area params buffer, we have the area params bytes. For uniform sets, we have which iteration we're on, we have our output buffer. What else do we need? We'll have access to the other buffer. Okay, so now we make sure that the shader is defined. Okay, we'll get the make buffer from out here. This is something that I could make a static somewhere. Because this is pretty uniform. It's make me a buffer that can house that. Or that and already houses. That can and already does house that. Yes. So we need our area params buffer is based on area params bytes. Okay, and then output buffer. Bytes. Excellent. Output buffer is going to need to be cleared. We should be able to do that. An array.clear on the bytes, yes. The area params buffer is going to be relatively fixed. Iteration buffers are going to be created on the fly and then released on the fly, same with our pipelines. And then we update this, which will be after the physics start step. Just like the collision manager, it's going to use an on for our world steps done. It will do its thing. We can do this one at the same time. There are other things that might need to come later. This is much more of a comes later proposition as far as how we're working on it. Okay, we will continue right after a quick break. Beverage. Let's see. Oh, we're actually going to need that compute boolean. Then in our collision manager as well, we're starting up. We are looking at these. On. Same thing for this one. So it's largely this, with some wrinkles to it. We're not doing the physics done steps. We are purging out our uniforms. We need to update that. We're not going to use the debug buffer. Check our output buffer. We're going to convert that into vec4s. So this one we need to be cautious about how we're dealing with it. Ultimately, what we might end up doing is having a pair of output buffers that we deal with for this one and use it as like an A-B set. Is whenever we get a fresh one, we set the actual output bytes, like the one to use, to whichever one we just updated. Then when we next go to get the data, we clear the other one and send that one up, and keep doing that so that there is only a particular time when the you're going to be looking at the data. That while it's fetching data, it still has access to the old output. So that we never have a period outside of the possibility of very, very briefly where you might check the data and get a different one. Like we set the other one to the new one before we clear the values. Is it possible if we go into an async world? Yes, but we'll cross that bridge when we get there. So we get our output data, we cast it in. This is where we would set the what our output is. We could actually store that off that way. Yeah. There's got to be a different way to do that. There's got to be something else with this one, because right now we're saying, here is the buffer. We're creating this memory for the buffer. This implies it's never actually keeping it. So we don't have to clear it because we're just allocating that space to say, this is what the buffer contains. We'll leave it as is for now. We're not messing with the wrong files. Just get an interim commit in there. Okay, so at this point, we have the resultant data. We can store this off. We could copy the bytes over. This really feels like wasted iteration, though. I'm curious. No references. This is a message. This is related to avoidance. Both of these don't need to be anymore. Again, since we're handling the entity data in a different location now, that buffer and related data, we don't need to be putting it everywhere. So I'm curious about output bytes right now. Maximize the likelihood that there is a collision in each frame when we do this. Starting now. Okay, and we're going to step over, get that buffer. There's nothing in output bytes each time. Oh. See, this is the address of the first one, but what I'm curious of is if they're the same thing. And this would imply that data is not the same thing. Right. Okay, now we should be able to look at data and see a result. Do not. What's going on? Would be near the end, but I'd be count index would be by uints. So we'd have count index times, they're 4 bytes each. Okay. Now we want output bytes. Okay, they're not the same thing. What good is that? I mean, it's like we're staging it into another location. That's it. We've got this copy that happens each time, which I don't think we can avoid. Be interesting if we could. But I guess we can't. Because it returns a copy each time, which means we're constantly going to be allocating memory for that. Oh, we're going to have to revisit that. All right, but so this is where we will do the thing. This is where we'll finish it, and we'll look at that data. But for now, we're just going to use that to purge that out. Now we need to do the actual iteration for the compute part. This going... It's gonna nab most of this stuff down through here. I see a problem for us right now. Because we're going to be calling sync multiple times. Which means we would need individual rendering devices for each one of these, which isn't out of the question. It's messy. It's very messy, but because we're going to have two different jobs almost simultaneously. And each one of them is going to do a submit and then a sync. So we're probably going to use a rendering device local to the avoidance manager for the start. But this creates one of the issues that I was worried about, and that's we need to wrangle which ones run concurrently and which ones don't, and how they'll play with each other, you know? So for now, oh, no, that's not where I put it. Should just copy paste that, but rendering device is equal to what get rendering device currently does. Which is that, and we're just going to say rendering device here. So we still get the same form of logic. We're going to need to figure out a way to have those layered rendering devices, or a good method of doing that. Either we're going to cache them off, or we need to have a way of cleanly generating a new one. I kind of like the idea of caching them off so that between iterations we don't create new ones. But given what we just encountered, we're probably going to need to make new ones each time. Oh, well. Not ideal, but There it is. Oh. That throws a wrench into the whole thing now. Because of this. Buffers are rendering device specific. All of this needs to happen. Each one of these managers needs to be talking to the same rendering device, and they're all within the same domain. So there's kind of like a grouping of them, which implies to me that we do need to have the rendering device be shared. But since we're still doing a submit in a sync on that same device, it's doing stuff. Said it had an overload, but oh. Second. All right. Let's begin. All the stuff that's part of it. We can't use get data async. That is a rendering shader part. It is not described well how to do it. Yeah, we don't have a good way to have multiple of them. And you can't tell what's going on. Like, you don't know if it's currently running. The act of asking for a sync will cause the run to stop. Again, this is part of the reason that I want to async this part, is to, within the other thread, to say, run it and sync it right away. Do this right now. Do we want to do that every frame? No, we don't, but we can delay some of it. Like, we don't need to do an update on the avoidance every time. But this is that state managing part, is I don't necessarily need the world to be updating on the Godot ticks. It can happen in its own flow, and that's that the program will circle all the way back around, even if there's asynchronous elements going on that are letting the Godot and rendering ticks continue. The state is independent of that physics tick. Now, we can keep recording it, and when we get back around to a particular state, we say, oh, look how much time has passed. We can start again. And that would avoid the concern with this, because they're all kind of converging. So for now, what we will do is look at our options here. So we are creating a compute list in this process. Get a rendering device, we add blah, 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 blah. So we create all of our uniforms, and now we go into a compute list begin, as well as creating pipelines. So we create the compute list, we bind pipelines to it. We set up a dispatch for that compute list. Okay, so what we want for this is that we want to get, we want to add this in. So we're going to do a little bit of a side step for now. We are going to set it up so that we can get an array of pipelines from our avoidance flow manager here. Voice is fading. Very least, take a sip here. Okay. Okay, we can create pipelines independently. This could get convoluted real fast. So the implication of this is that there's effectively a physics shader step that we're going to do. need to be able to get uniform sets. We get an array of uniform sets. We get a we're creating pipelines off of a shader, and we're binding that pipeline and that uniform set. And then dispatching the compute list each time. Okay, yeah, we're creating fresh dispatches on that compute list. And this is what lets us submit. Like there's got to be a better... Feels like there's something missing here. But it's functional as is, so... What we need to do then is get... After this step, we're saying get... Okay, no. We'll pass the compute list in and let ours do its thing. Okay. And we're not going to bind this thing right away. We're just going to instantiate it within the physics logic and keep it around until the end. So we're not going to bind to these. We're going to have this done forcibly. We're going to use the same rendering device that the other one does, though. So what we could have is that we could be saying that there's some sort of identifier to the rendering device that is shared. We'd have to figure out how to do that, though. Like, the logical flow for it. Anyhow. So we have the same one, but we're not going to submit in sync here. And we're not going to rely on this. So we get a compute list, and we're going to do this here. We're going to do a lot of what this one does leading up to it. All right, let's go through here and start carving stuff. Entity data uniform, there's our output uniform. We don't need a debug uniform. We don't need to clear output bytes. Okay. Then we need, from our flow generator here, we need our flow image param set up. Here. Key, there are just all of the layers in a VTuber model. And then on top of that, the rigging of it gets crazy to account for all of that, especially when you have, like, you know, stretch and bounce on it, associated physics, that kind of thing. I looked into Live 2D, and on top of the fact that all of the documentation is primarily in Japanese and then clearly translated, just the workflow is substantial. That there's a reason that the rigging is its own skill set, that the rigger is called out as an artist in their own right in the process. It certainly can't hurt to be able to speak Japanese yourself. Avoidance param. Need Okay. Set those values. We create the buffer with that. This is effectively permanent now. We don't need to worry. We don't need to worry about ever updating the area params buffer. So look here, we have area params first, then our data buffer, then our iteration, then our output. This is an area params buffer. I mean, in theory, we could keep this one around because it's always going to be that. But we'll just iterate on it for now. Then entity, then we need iteration. Okay, we are... Here we go. No, we define it right there. Weird. So what we're up to here, get rid of you. Yeah. We're just setting up this loop of iteration. We need to make sure we get our binding order correct. So we have area params is 0, entity data is 1. Then iterations is 3, I think. Iterations is 2. And then output is 3. Put uniform after hopefully it lets me do it out of order like this. Collision manager, where are we setting up this? Okay, iteration buffer in bytes. Create all of those. When this one exits tree, we need to put this stuff in the destructor of this other one. Avoidance shader, and then we free all of the buffers. When do we free the pipelines? I think we free the pipelines in exit tree, right? Oh, we free them when we're reading. Yeah. We have a public void cleanup. Okay, we purge our compute pipelines here. Entity iteration, we also need our area data uniform. So we create the new iteration, we create the uniform set. Then for each one of these, we make a pipeline and we dispatch on it using the number of work groups we've got. Then during cleanup, we purge all that out. Have a get data method. Which will not be calling sync. Okay, we do that at the end of get data. So then in the shader collision manager, hey there, Laura. We're just going to explicitly implement that one right here. Build. We run. Nothing explodes. Jump over to the Godot side. How's it going today, Laura? Build. We run, we switch over, nothing explodes. Nothing explodes. Okay, that's good. The very firm declaration of, we're done here. Oh, it's going to be such a mess to get the actual workflow in there. Collisions. Now, before we do compute list end, we do avoidance flow generator dot add dispatch, and that needs compute list. Oh, that's not good. That's real bad. Godot, tell me what's wrong. Oh, that's real bad. That's very broken. During add dispatch. On 170. Oh, we can't do this. Okay, we have to break this apart. Iterations buffers never change. As soon as we create them, we're done with them. As far as like, they exist, we're good. Yeah, we can just do the same thing here. So we set this, we iterate over it on I, and we store off a uint in it, and we set the buffer using that data. So we know we've got the size of it. It's 1 uint. So we can say iteration values as a uint of I. Sorry, 0 is equal to uint of I. And then we update it. That buffer is permanently ready now. We don't need to call update buffer on it. Because we're getting the corresponding buffer. Something different here. The pipeline, we bind the uniform set. Then we have to release the uniform sets later. Oh, okay, we create it here. We're not keeping the uniform set. We're creating a uniform. Okay. Build. Stop. Run over here. Alt. Look. In add dispatch, it says we're still updating a buffer. Oh. Okay that we do it here. Well, it's not ideal that we do it here. It's the same problem. We set up the function that would make that unnecessary, but we were still doing it. Still a problem. Dating buffers. 184 this time. I don't think we actually need to do this. Finding to set 0 not provided. Storage buffer for params, entity, iteration, output. Oh. We're doing this twice. Iterations is binding 2. I'm finding flaws in the existing logic as well. Okay, now this is just fantastically slow. So now we're facing the other side of the problem, is that we are creating a whole bunch of extra iterations and then retrieving the data. Yep. So this is just really, really slow, what we've done here. The iterations that we're creating are insufficient. And even asyncing it, we've got a problem. So we're not doing an exceptional amount of processing here within each one. We could potentially do fewer iterations. Because each one of these is running over the entities. We do 16, we can do 20 here. We do 32 and do 10. Five. It's too many. Okay. Still really slow. Oh, and that's not enough anyway. That's 1024. There still needs to be 20 in there. So 8 by 8 by 8 still needs 40. Because that'll be 512. And we need to cover 20,000 entities. We could break it up further and only do particular subsets by controlling the iteration number that we do. You know, do X% of the entities each time. This is also too much. If we just do 1921, Let's be generous and we'll do one full screen on each side. No, let's do 2001, and then the height be 101. Reduce processing. Okay, we're back up to a reasonable baseline here. Okay. We need to control this. This doesn't need to be much. It just needs to be a little more than the size of the screen, such that unless they're visible, as long as they're not visible, they don't need to do avoidance. As soon as they are visible, now they need to start breaking apart. Okay, so we have this logic. There is a big hurdle in front of us, and that's getting the shaders to play nice. We need to be able to submit portions of a job to this and make it run more clean. That's going to have two necessities to it. The first is making it so that we can consolidate this stuff. There is a way to say, hey, this rendering device is the one that we're creating, and we're adding to that rendering device. The other is getting it so that the process takes the time that it needs to run. One of those is going to likely be putting this in an async and doing a wait on it. Side quest, what we're doing right now. Oh, let's... I actually want to see what this looks like in a moment. Let me add something to the shader here too. This W is equal to 1. So what we've got is we're making a survivor style game, and we're trying to hyper optimize because one of the things that we're shooting for is to have a lot of things on screen and to optimize for that as much as possible. The reason that we have to optimize more is that the logic for the movement of the various things is more complex than just fire a projectile and it does a fixed behavior kind of thing. Individual projectiles have, like, each individual bullet can behave as its own thing. So we can't use just particles and fixed duration math to know where it is. Like, we have no idea that it's going to move in a straight line, even if it starts out moving in a straight line. At any moment, it could just start spiraling all over the place. Okay, we've got that. So then at the end of the base avoidance flow generator, we are going to have it stamp out an image based on the output data that it has. So we'll save that off in a corresponding byte array. We could just do a span vec4. Yes, each with its own individual physics behavior. Am I not allowed to? Boo. Okay, fine. No. Stop trying to be helpful and inserting things that potentially need libraries. Here. That'll do that, Key. Posture is important. So each one of these mice currently just homes in on an enemy target. So let's start again. But I can make each one of the mice replicate itself 3 times over the course of a second, add some zigzag to it, and move in loop-de-loops. So they're doing that immediately. But I can also say that that happens after 3 seconds. So this mouse here, after a 3 count, is going to behave differently. Here, we'll do it a little more dramatically. After a 3 count, split into 3 and then burst into a ridiculous number of projectiles and then orbit the player. So about now. Yeah. That is the expensive part of the code right now. Or that is a substantial expense in the code paired with the fact that we want to be able to have the outside case that we're dealing with. Oh, our frames are plummeting right now. But we do actually cap out, there's a particular bottom out that is still above 1 frame per second. So for reference, there's about 1,800 things active right now. Each of them has its own chain of behavior, its own health number, and anything about them can change at any moment. Every tick they can change. 20,000 is the cap. If we hit the cap, they start spawning. You should never hit 20,000. I refer to this as our calamity case. If the player gets to the calamity case, I don't really care anymore. They've kind of won. Like, if you can reach this, there's very little that the game would have been able to throw at you. It does not crash when this happens. I am likely to need to add some sort of failsafe for if this happens, but it would likely be a don't explode failsafe, not a let the game try to continue. But we have 20,000 things. We're getting about 6 frames a second. If we cut that number down to something a little more sane, it will take the in-game equivalent of 10 real-world seconds, which right now is much more than 10 real-world seconds. The game moves at an absolute fixed tick rate. So no matter how long passes in real-world time, whenever the game gets a physics step, whenever it gets to update the world simulation, it treats it as if only a particular fraction of a second has passed. They're bursting out like this because their AI is such that, or the behavioral script that they use is such that when they lose their target, they try to reacquire. So once the wave goes out and slaughters everything, the ones that didn't get to hit their target reacquire and try to loop back around. But we're dropping back down to doing 3 to the 4th projectiles per second. And you can see as they die off, performance kicks back up. This is at 590 things. About 500 things, let's say. We get, right now, about 110 frames per second. We've got it capped at 120. It can go higher. When I set it to uncapped, it was able to get up to a few thousand sometimes, but the few thousand is irrelevant. I think 3 to the 5th will start it to go over 1,000. They view the little spawner blob as a target, but the spawner blob cannot be hurt. So right now at about 2400, we're getting 43 frames. Let's say 40 frames. So that has been part of the cost from the additional shader logic. Okay, so we're going to store off the bytes each time. So we store off the bytes, then during the destruction here, man, such a mess. Memory Marshall dot cast from byte to vector 4 or zero I is less than flow width. Int I Okay, we're gonna set a image to that. So for that one, if we go to our base flow generator, we should have a place where we're outputting it to image. Should actually be able to use this. Okay. We're doing a little bit of hackery here at the moment. Data. We're saving an EXR format because that lets us have full floating point values in a color, as opposed to limiting us to from 0 to 1. Jump back out. Look here. Did we get one? Don't think we did. Let's run it on the Godot side and see if it catches an error. Did not. Maybe we need a more robust path. Yeah. Res dot. Okay, we didn't get a result from that. Back over to the Godot side. The Godot side can catch errors that the C# side won't. Interesting. Okay, we're never clearing this. Okay, let's explicitly null it then. Why are we never deconstructing this? Weird. Just in case. Okay, still nothing created. Tell me more Godot side, please. Okay. Gigantic span, yes, yes. I think we're going to call it here for now. We've still got some issues to work through. What we were trying to work on today was avoidance logic. We made some headway. It is clear that we're going to need to work on the performance of this thing. I know, right? Is avoidance crucial? No. Do I want to do it anyway? Yes. Is there a way around us dealing with this? Yes, there is. We could set up things like quad trees. We can clean things up. We can make it more efficient. But we'll have to see. There are things we haven't done yet. But avoidance is something that I want to deal with. But yeah. Let's see. Progress was made. We are going to try to have at least one more stream this week. Ideally, it will be tomorrow, but we'll see how that goes. Either tomorrow or over the weekend. I do want to get those, at least that Friday, Saturday option rolling. And I do want to get some gaming streams in. I wouldn't mind doing another detective game. I've got a couple of them lined up. Well, investigative games. But we'll see. Making good progress on the game, so there's motivation for that, you know. But in any event, folks, I hope you had fun with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment. All those buttons are generally good, so please press them. If you'd like to consider financially supporting the channel, you can do so through platform-specific means as well as other options available through the link tree that is in my video descriptions and bio. And with that, I hope the rest of your day is good, and I will see you next time.